Today we're looking at lesson 2-3, which is on conditional statements. I wanted to explain some of these wordings for you. So the first, which is very important in this particular lesson, is to determine the statement in an if-then format. So you would have a hypothesis, which would be the if part of the sentence or the statement, and then you'd have the conclusion, which would be the then part of the statement. So if you have a statement such as, if the forecast is rain, then I will take an umbrella, that would be in if-then form. The hypothesis of that would be, the forecast is rain, and the conclusion would be, I will take an umbrella. So the if part and the then part give you hints on which is the hypothesis and which is the conclusion. Then you have what's called related conditionals, and these are different ways to write the statement. So we'll do these in a little bit later, but you have the converse of a statement, which means if you put it in if-then form, you're just switching the hypothesis and conclusion, or the order of them. Then you have the inverse, which again, all of these need to be in if-then form first. So if you have it in if-then form, the inverse is going to be negating both the hypothesis and the conclusion, or making them have a not, the word not. Then you have contrapositive, which is negating, okay, like you did with the inverse, but you're going to also switch the order of the hypothesis and conclusion. And when you think of these statements, there's some that are logically equivalent, meaning it makes sense that they would be equal. So a conditional and its contrapositive are going to be considered equivalent, and then the converse and the inverse of a conditional are going to be considered equivalent. So we're going to identify the hypothesis and conclusion of each of these conditional statements. We're going to look for where it has an if and a then, and if it does not have an if and a then we're going to make it in if-then form to make it a little bit easier. So if a polygon has 6 sides, then it's a hexagon. If we're identifying the hypothesis, we look for the if. So the hypothesis would be this part of the sentence, and then the conclusion would have the then part, so it would be this part of the sentence. Then if we're going to go to the next page, this is going to give us another statement, but this is not in if-then form. So if we make this in if-then form, we could rewrite it and put the if part first. You have if the first performance, it says if the first one, but they're talking about performance. So if the first performance is sold out, then another performance will be scheduled. So once we put it in if-then format, we can easily identify the hypothesis and conclusion. So we identify the hypothesis as the if part, so if the first performance is sold out, and the conclusion would be the then part, which is another performance will be scheduled. Then we're going to write these statements in if-then format, and we're going to also determine what is the hypothesis and conclusion. So we're going to do a few more examples like that. So this says 4 quarters can be exchanged for $1. So if we put an if in here, we could say if we have 4 quarters, then we can exchange for $1. I ran out of room here. So in white, we've put it in if-then format. So to identify the hypothesis, we're just looking for the if part. So if we have 4/4, and then the conclusion would be the then part. Then we can exchange for a $1 bill. Then we have the sum of the measures of two supplementary angles is 180. So to change this into if-then format, we could add an if in the beginning. So if the sum of the measures of two supplementary angles, actually, let's think about that. If the sum of the measures of two angles is 180, so we're going to rewrite it. If the sum of two angles, and not include the fact that they're supplementary. So if the sum of two angles is 180, then the angles are supplementary. Excuse my handwriting here. So you need to think about what would be the logical conclusion when you start your sentence. So if you have two angles that are 180, adding them up would be considering the angle supplementary. So we continue the sentence with the then part and say the angles are supplementary. So this would be our hypothesis, and this would be our conclusion. The next part, we're going to work with the conditional statements. So we're going to think about the truth value of them, whether they're true or false. And then if they're true, we're going to explain why. If false, then we're going to try and give a counterexample. So here we have if angle A is an acute angle, then angle A is 35. So we need to think about if angle A was a different measure. So basically, there's another option for an angle being acute. It does not always have to be 35. So we would conclude that this is a false statement. And a counterexample would just give another number that would be acute, but it wouldn't be 35. So they chose 55, but really anything from 89 to 1 degree would work for a counterexample. Here we have if the square root of x equals -1, then if you square -1, then it has to also be -1. This is a tricky one because you never have a square root of anything be a negative number, but based on the hypothesis and then the conclusion of that hypothesis, we actually can say that this is true, because the conclusion matches the hypothesis. Now we're going to work on the other conditionals, the related conditionals. So you have a converse of a statement, the inverse, and the contrapositive. So we're going to be given a statement, and we want to make sure it's in if-then form, and then we'll write each version of the conditional, and then we're going to determine whether each version of that is true or false. And then if the statement is false, we're going to find a counterexample. So the statement is a hamster is a rodent. So if we put that in if-then form, we can say if it's a hamster, then it's a rodent. So this is our if-then statement. Now we need to write the converse, the inverse, and the contrapositive. The converse would be to flip the if and the then. So we would write if it's a rodent, then it's a hamster. And we need to think about that. Is there only one kind of rodent? And is a hamster even considered a rodent? And both of those would be false, so we would say the whole statement is false. Now, a counterexample would be any other rodent. So you could say mice, or you could say rats, or you could say any kind of rodent, chipmunk, something like that. So those would be that would be a counterexample. Now we need to do, and that was the converse. Now we're going to do the inverse. The inverse means we just negate, or we put a not in front of each statement. So we have, if it's not a hamster, then it's not a rodent. And we go with the original statement when we do this. So if it's not a hamster, then it's not a rodent. So we need to think about the idea of this being true. So what we have is this would be also false, because just because it's a hamster doesn't mean that it can't be a rodent. So if it's not a hamster, since we have other ideas for what a rodent could be, let's say it's a mouse instead, it still could be a rodent. So it doesn't always have to be a hamster to be a rodent. And again, we can use the same idea or counterexample as we did before, mice. Whoops. Then we have one more type of statement. That's the contrapositive. And that's negating the hypothesis and flipping the hypothesis and conclusion. So if we go back to our original statement, if it's a hamster, then it's a rodent, we're going to say if it's not a rodent, so I'm flipping the hypothesis and conclusion and also putting nots. So if it's not a rodent, then it's not a hamster. And that would actually be true, because a hamster is a rodent, so if it's not a rodent, then it's not a hamster. We could say that is true. So we don't need an actual counterexample there when it's true. Then we have one more statement where we need to make it into if-then form and then write its converse, inverse, and contrapositive. So this says two angles that have the same measure are congruent. So we could say if two angles have the same measure, then they are congruent. And the converse switches this, so we're going to say if two angles are congruent, then they have the same measure. And since this follows the definition of congruent, this would be true. And that could be your explanation. Then we do the inverse, which is negating the hypothesis and conclusion. So if we go back to the original statement, we're going to say if two angles do not have the same measure, then they are not congruent. So this would be considered true because you have two angles that are not the same measure. Since that's the definition of them having to be congruent, then we can conclude that they're also not congruent. So this is a true statement. And then the last one would be the contrapositive. So we're going to switch the statement we just wrote to say if the angles are not congruent, then they do not have the same measure. And this would also be true because if you think about angles not being congruent, if they're not congruent, then the definition has to be that they are not the same. And that concludes lesson 2-3.